everyone. Welcome to today's roundtable. Our topic today, API security, trends in 2022 and best practices. My name is Sella Rafaeli. I am VP Solutions at WIB. As part of our work in API security, we get to interface a lot with clients from various industries, financial institutions, healthcare providers, communication companies, and what is common for all of them is that they are gradually making progress on their API journey, gradually realizing and learning the power of APIs, not just in terms of productivity, but also in the sense of the security that needs to be applied to such a potent connection between the outside world and the business logic and applications. Over the last couple of years, we've really seen the API security community grow and mature. More and more people are realizing the security implications of robust APIs. The more power you give your users, the more potential for damage you give your attackers. And by now, most enterprises realize they are reliant on their APIs and on their APIs to be secure. So the most basic feature of API security is production defense. And this is the solution that most companies are working on, sort of a WAF replacement for APIs. However, we are also seeing more and more companies learn that this is not enough and focus on additional vectors that are necessary for API security. In today's talk, we review 6 trends we have noticed are particularly prevalent in companies with sensitive APIs. These trends are as follows: a dedicated technical platform for API security, attack simulations, code analysis, SOC as a service, focus on compliance, and a full lifecycle approach. Each one of the trends, but especially all of them put together, help us paint a clear picture of what makes up a complete API security defensive strategy in companies that are mature, or at least further along what we call their API security journey of adapting their security practices and set up for the new #1 attack vector on organizations. So the first trend, dedicated tech stack for API security. WAFs are tech from 1917, not quite fit for APIs, the #1 attack vector, which is very fragile for defenders, but a goldmine for attackers. API security is an uneven arms race, and 22 is really the year of the API security solutions. So the first trend that is important to understand is using a dedicated tech stack for API security. Really, this is the hallmark sign of the maturity of the field of security teams realizing that the benefits provided by APIs, direct programmatic access to internal business logic, is also rife for abuse. So as part of the cybersecurity arms race, the realization that API attacks don't just carry with them an enormous potential for damage, but also attacks on APIs are not properly detected or defended by existing standard cloud security products. Chief among these tools is, of course, the WAF. By now, I think we all know that by design, WAFs cannot defend API attacks, which are generally predicated on logical problems in the defended code rather than specific payloads which can be detected by rule-based engines. It is interesting to point out that the same trends we see in warfare, where armies are often fighting the previous war, building solutions to counter the enemy's strategy, but their strategy from the last war. So in a similar fashion, attacks have evolved and API attacks cannot be stopped by WAFs, and so security teams realize that they need a dedicated tech stack for API security. So trend #1 that we see in this space is, from a defensive point of view, the understanding that the security cannot rely on shoehorning new features into existing platforms or relying on newer versions to take care of this new attack vector. In 22, we are seeing the widespread adoption of API security-specific platforms in every organization that is mature enough from a security perspective. Trend #2, attack simulations. Attack simulation is the choice to proactively simulate a sophisticated API attacker and find public vulnerabilities first before a malicious actor does. The best defense is a good offense, using military-grade nation-state abilities to simulate a powerful adversary. So trend #2 is somewhere between offensive and defensive. This trend is actually a counter trend to offensive advances in API security and is a perfect example of the kind of arms race effect that is so common in cyber warfare. It starts with advances in offensive cybersecurity warfare becoming mature enough to both become a more prominent risk as automatic attacking technologies and strategies proliferate and become available to attackers of various sizes. So abilities that used to be found only with very advanced, usually nation-state actors, gradually leak and become more and more commonplace, more commercial, more standard, more prevalent. And as the offensive abilities grow, so do defenders learn, at the very least, to practice against them. Such, too, is the case with API attack simulations. APIs are a formal programmatic definition of a server interface. They are particularly amenable to programmable attacks. Since constructing a single attack on an API is relatively simple from a syntactic point of view, since accessing the API endpoint with an automated solution is the whole point of an API, the semantic bar for the algorithmic logic behind the attacks is set higher, and attacking engines like Wib's attack simulator can focus on the sophistication of attacks. So what we see is many organizations take advantage of this aspect, in parallel with firms like Wib that create white hat attack simulators that can simulate all possible attacks against an API, and by analyzing the responses, find all the vulnerabilities in the API. The value here is obviously very high for the organization. By formally simulating an API attack on the APIs themselves, the organization can find their vulnerabilities first. This technique is especially beneficial when connected to a CI/CD process to enable running such a simulation upon each deploy. Really, this trend makes so much sense because the downside for the organization is negligible, but the upside is possibly finding and fixing API vulnerabilities that could be so harmful is not taken care of in time. So the way an attack simulation generally works is that the input is some file defining an API session, and then the attack simulator creates many variants, each representing an attack, one potential possible API attack on the server. All the attacks are executed, all the responses are analyzed, and using this logic, we can find all the responses that denote a vulnerability at the API. Next trend is called code analysis. It is analyzing your code base to find all API security issues and to build a map of your endpoints and vulnerabilities. This helps connect the security team with insights they need at the code level. So this trend, code analysis in the context of API security, is especially interesting because we are also seeing this as an example where API security grows and seeps into other security fields as part of the well-known trend towards shifting left and trying to defend and solve issues as early as possible in the code lifecycle. The main value of a code analysis solution for API security is the ability to scan from the code the list of all defined endpoints. Really, it is quite scary to consider that today most security teams have zero visibility as to what APIs even exist in their organization. This is another point to reflect on how development teams have led kind of a revolution, the API revolution, that has completely transformed the possible access patterns into an organization's data, while security teams have been left completely in the dark in their ability to follow or even have visibility or awareness into what goes in and out of the organization via these APIs. So the way enterprises are now adapting to this new reality is by integrating a code analysis flow solution, which scans the code at rest, and its output is a list of all the necessary information for the security team from the code. Which routes exist, which HTTP methods does each route support, what aspects should the security team know about each route? For example, does it require authentication? Does it expose PII? Is it vulnerable to standard API attacks, such as BOLA? What's funny is that from a non-developer's point of view, say from a business security perspective, this is something that is absolutely obvious that the security team needs to have access to. However, the lack of transparency caused by the walls of expertise around software products, what I like to call the fog of tech, has left this need in relative obscurity. So now security teams are finally catching up. Security teams need to know what APIs they have coming in and what APIs they have going out. This need is not a technical need, it's a security need. You can't defend what you can't see, and you can't enforce security schemas and rules without having the visibility that they are indeed being enforced by your teams. So what we often see is that a particular pattern, especially in agile teams that use a microservice-based architecture that deploy often, so they might update their APIs once a day or even more often to production, is a pattern that the security team is relying on an API gateway to enforce various forms of runtime security. But then developers can go ahead and launch services with ingress routes that are exposed to the world and bypass the API gateway. So in such a case, relying on the API gateway is not enough because developers can always deploy code that bypasses it, and this often happens. And the kicker is that the security team has virtually no way of knowing that this even happens. So this is why code analysis of API security issues and of API endpoints, both ingress and outgoing, is such a blessing for security teams and becoming more and more prevalent. Our next trend, trend number 4, SOC as a service. Outsource alert and event monitoring, leverage others' security expertise, don't roll your own API security, roll operational overhead, risk, liability, and noise onto a vendor. So this next trend, SOC as a service. SOC, a security operations center, is the business unit tasked with monitoring alerts coming from all security products and investigating each alert and notification to try and make sense of what has happened and to respond to it in a manner that is both timely and appropriate. Now, this challenge is infamous within security circles, as most security products are, or at least tend to be, very trigger happy with their alerts and false positives that somebody needs to deal with. So every security product inevitably comes with its alerts, false positives and otherwise, and the organization's SOC must keep up with handling all of these alerts, which is a challenge in terms of logistics, manpower, expertise, experience, and ultimately security. Most importantly, this challenge, handling a security operations center, is one that generally falls far outside the business acumen of each organization. If your enterprise is in the field of health, finance, telecommunications, e-commerce, or almost anything else, for this particular enterprise, security is, even on the best of days, a necessary evil, not the main domain in which they focus. For them, it's something that needs to be taken care of, but not a domain that is their core specialty. It is literally not their business. And trying to take care of issues in which you are not an expert for any individual and organization can be a harrowing task. This is especially true in security, where lack of proper experience and expertise can have terrible results, of course. This is why in many areas of security, the common suggestion and wisdom is don't roll your own. So this is why we are seeing a trend of outsourcing SOC operations. This allows the enterprise to delegate all such security monitoring and handling to a provider who specializes in such work. This makes a lot of sense and is another sign of a maturing industry. Just like few enterprises handle their own physical security and prefer instead to outsource such work to a physical security firm, so the realm of cybersecurity also benefits from enterprises focusing on their core business and services and delegating the security operations to a firm with expertise in that domain. This allows the enterprise to rely on a firm that specializes in cybersecurity operations and can perform as a professional SOC and benefit from a wider and deeper understanding and experience of tools in the field. Perhaps most importantly, this lets the CISO sleep easy at night, as he or she have delegated and outsourced the security monitoring, security as a service to the extent possible. We're on to trend number 5. Trend number 5 is a focus on compliance within the world of APIs and within specifically the world of API security. It assumes a legal panel for all API-related issues for the security or executive team and is tasked with ensuring legal and regulatory API compliance. GDPR, HIPAA, CCPA, PCI, open banking, there are many, many standards, and each enterprise does today, and with every day more and more, needs to ensure that their APIs maintain legal compliance. So trend number 5 from a legal perspective is the coolest of them all. We discussed how the rising level of general technical education and the prominence of API attacks and API security is fostering a wider awareness of the importance of API security, also aided by the rising tide of API attacks garnering media attention. It seems every day there is another massive breach. While this is unsurprising perhaps for our technical audience, as we are well aware that any API breach can lead an attacker directly to the database, where the attacker might get access to all user data, the general public, as well as lawmakers, have been taking note as well. Regulation of enterprise activity as relates to user data and privacy controls is a real thing, and especially the European and North American regulators are gradually enforcing provisions to ensure that providers are careful with user privacy and data protection, and they too are aware that APIs are the #1 attack vector. So what we're often seeing is more and more awareness at the legal compliance level for regulators enforcing standards on enterprises and on their APIs. We are seeing more and more specifications at both the country and industry level as to ensuring that enterprise APIs are compliant. We've all grown to love our favorite standards, HIPAA, GDPR, PCI, SOC 2, and so on, ensuring that our data is safe. And now we are seeing waves of API-related regulation and compliance monitoring grow. This is not just from legal entities, but also notably from entities such as cyber insurance companies, especially in the growing cybersecurity field. So in response, enterprises are adopting tools that can help them deal with enforcing, monitoring, and reporting the compliance status of their APIs. Which routes exist, which routes expose PII, which routes have been audited and when. In some ways, it is bittersweet seeing the end of what we might remember in the future as the Wild West era of the API days, when developers could connect anything to the internet with some duct tape and call it a day. On the other hand, legal privacy compliance is great for all of us. We have reached our final and most important trend, full lifecycle approach to API security. And this is because more and more people are realizing that true API security requires a full lifecycle approach in development, testing, and production. So if you take production, traffic inspection, add code analysis, add in-tech simulation, add compliance defense, this is your way to get to full lifecycle API security. This final trend is sort of a meta trend, and yet another reflection of how the space, the API security space, is growing and maturing. It is the realization that, as in other fields of security, API security does not have a single golden bullet that can cover an entire organization's needs. APIs follow an organizational lifecycle that spans different departments and phases and introduces various angles that all must be covered. This is a task for a suite of systems, not a single one. In short, enterprises have realized that API security requires a holistic approach that covers the full lifecycle, from development through testing and staging, naturally to production, and that all of this data needs to be aggregated together to present an encompassing view for compliance. So once again, API security, as a young-ish field within cybersecurity, is learning from its predecessors and other security arenas and follows parallel tracks. So we are now requiring static code analysis for API security, dynamic testing via attack simulations on APIs, and naturally a production defense via traffic inspection. All of this, in order to have all of these together, form a full lifecycle solution for the organization, which can then be piped into a compliance view for the security and executive teams to have a unified view of the regulatory status. In short, this is the single most important trend in API security in 22, the full lifecycle approach. Using a full lifecycle approach is the only way to provide full API security for your organization, the only way to ensure your security team is on top of all of APIs, exposed via the code, testing each and every one of them via an attack simulation, and defending all of them from abnormal, malicious attacks via traffic inspection. We are a young industry, but we learn quickly. Attackers aren't the only ones innovating out there. So, this concludes our review of the most common trends in API security in 22. We covered a dedicated technical platform for API security, attack simulations, code analysis, SOC as a service, focus on compliance, and a full lifecycle approach. Now is a good time to discuss this as part of our roundtable and take any questions from the audience and from you, Elizabeth.
Thank you so much for that very detailed coverage for trends. I think I'm going to throw one question at you since we're coming up on time, which I think could kind of encompass what you've talked about as being a young industry. And the question is, where do you see API security in 5 years? Will we still be getting popped left and right? Do we think at any point security settings will actually be secure by default?
It's an excellent question. API security is such a young field that in 5 years, I mainly expect it to be much, much larger. It is kind of like the new cloud security. Maybe older ones among us remember when cloud security became a thing and when suddenly everybody realized that putting all of your stuff on somebody else's computer might not necessarily be secure by default. And so an entire industry, the cloud security industry, arose along with vendors and best practices and conferences and strategies. I expect API security to go down the same route, where first of all, widespread understanding of the importance of security of APIs and how potent of an attack vector it is will become more prominent. And as education rises, so will best practices for defense, as well as the ever-improving abilities of attackers will improve. We will never have complete security. That is not a thing that seems reasonable to envision in this world. And having secure by default settings is kind of a misnomer because we will always focus on whatever issues were forgotten. We will I appreciate the dad joke comments in the chat. So in 5 years, there will be a lot more awareness, first of all, for API security. We are already seeing how non-technical actors are suddenly realizing the possible effects of open routes connecting random strangers straight to the company private data, and people are understandably alarmed. So API security in 5 years will be more mature, more developed, higher awareness, more mainstream. Will we still be getting popped left and right? That's a good question because the rewards for successful API attacks are so high that attackers are becoming not just more and more motivated, but more and more organized, more funded, and cyber crime is becoming commercial with nation state abilities. So I expect the landscape to continue to consist of an ongoing conflict between attackers and defenders for the arms race to continue. And hopefully the defenders will stay with the upper hand. I do want to mention Chuck's comment from the chat. Chuck says, I wish we'd have solved this in 5 years, but banking still runs on mainframes. It's tough to get rid of the old tech. I'm guessing we'll continue to see more adds than replaces. We still see code today that's vulnerable to the OWASP top 10, and that's 19 years old. So wise words, and certainly API security will not be solved in 5 years, but at least the enterprises that care enough will have a fighting chance against the attackers.
And we'll close out on those words of wisdom. Thank you so much for your time. Thank you, everybody who joined.
Thank you, Elizabeth. Thank you, everyone. Have a good day.